All right, let's take a look at another example. These problems can actually be quite tricky. So this one asks us to calculate the cell potential for the following cell at 25 degrees Celsius. And then it gives us the cell, right? It's a tin and silver cell. And so we're at 25 degrees Celsius. So that means that we can use a bit of a simplified equation here. And we know that then the cell potential is equal to the standard cell potential minus the 0.0592 volts over N times the log of Q. So let's go ahead and figure out one by one how to figure all this stuff out. And so the first thing we have here is E cell. Remember that E cell is equal to the E of the cathode minus E of the anode. And so we have to figure out which one's the cathode and which one is the anode. Again, you can't just assume that this is going to be a spontaneous reaction. It might be or it might not be. And so remember that the electron flow goes from left to right. Right, so the tin is going from tin to tin 2+, and then the silver is going from silver plus to solid silver. And so what we can see here, what the tin is undergoing is oxidation, right? It's losing electrons, and that occurs at the anode. So the tin is the anode. So we have to find the tin, the potential of tin, and we're going from tin 2+ to regular tin or solid tin. And then on the other side, we have reduction occurring. So that's going to be the cathode. And that's from silver plus to solid silver. And so we have to use our table to figure this stuff out. And so you want to be very careful with what values you're pulling from the table here and make sure that you're pulling them correctly. So notice here that we're going from tin 2+ to solid tin. So you have to be careful when looking at the table. So one thing you might notice here is this tin 4+ plus 2 electrons to tin 2+. That's not our reaction, right? You can't just look for tin. You have to look for the specific reaction. In this case, we're going from tin 2+ to tin 0. So we have to find that one. And that one's actually down a little bit further. So the real value here is negative 0.14. Right, so make sure you're pulling the correct value. And then we go from silver plus to silver solid. That would be at 0.8 volts. And so when we calculate our cell potential here, we get an E cell is equal to 0.94 volts. And so we can take this number right here and then plug it in for our E cell. So we've taken care of that. Next up, we've got N. Remember, N is the moles of electrons that are being transferred per reaction. And again, we want to be careful about this. So let's rewrite our cell notation as an equation. And remember, this guy right here, although it's on the right side, it's actually a reactant because it's getting reduced, right? So it's Ag plus going to Ag solid, right? So that Ag is on the left side. And same thing, and then this tin 2+ will go ahead and be on the right side. And then we have to balance things according to charge, right? So we see that we have a 2+ on one thing, a plus on one thing. So we have to multiply the silver by 2. Right, and now we've got a balanced equation where it's balanced in terms of charge and elements, and we see that we're seeing a transfer of 2 electrons, right? There's 2 silvers losing 1 electron, that's 2 electrons, and then the tin 2 is losing 2 electrons. So our value here should be 2 electrons, right? The silver, there's 2 silvers gaining an electron, and there's 1 tin losing 2 electrons. And then finally, the last thing we kind of want to think about here is our Q. What is our value of Q? So remember, Q is your reaction quotient. So it's the products taken to the coefficients over the reactants taken to their coefficient. So some couple things to be careful about is first to identify what's your product and what's your reactant, right? Even though tin is on the left side and silver is on the right side, when you write out your actual equation, they get flipped, right? They get flipped. So here, silver is the reactant and tin is the product, right? If you look at your chemical equation that we wrote out, that's the correct way to think about it. So it's tin over silver. And then the other thing you have to kind of concern yourself about is the coefficients, right? There's a coefficient of 2 for the silver. So we need to square it in our Q. So this will be tin 2 plus over silver plus squared. And then we simply pull the concentrations from the data given, right? This is 2.63, this is 0.0043. So this will end up being 2.63 over 0.0043 squared. A lot of people forget the exponents here, right? A lot of people forget the exponents, and then a lot of people mix these two up, mix the product up and the reactant, because it is a little confusing if you're just looking at the cell notation. And so then we just take this value here, plug it in for our Q, and then plug and basically just chug through the problem at this point, right? So our E cell is then going to be equal to 0.94 volts minus 0.0592 volts divided by 2 times the log of 2.63 over 0.0043 squared. And then plug and chug through that, you'll get 0.79 volts as your final answer.